Okay, I would like to welcome everyone that logged in today at our Zoom meeting for NEOACM. Today we are going to have an open discussion on whether there is a crisis of reproducibility in science and engineering. And to start this off, we want to play a short video that's going to summarize this topic and introduce some of the issues concerning reproducibility.
Before I do that, I want to let you know that in the chat, I did put a link to a Google Share that has links to this video and our other resources. And I also, for those that are on the phone, I think it was John, I sent an email out as well with that link.
Okay, thank you.
Oh, this is the video that's on the screen.
No,
No,
this is the video.
What was I looking at on the screen?
That was just a screen.
Oh, okay.
Is there a reproducibility crisis in science? Nature asked 1,500 researchers this question as part of an online survey. Half agreed there's a significant crisis, and many more identified a slight crisis. Science moves forward through corroboration, when researchers verify others' results. But 70% of researchers who took our survey said they'd tried and failed to reproduce another group's experiments. And even when trying to reproduce their own work, just over half said they couldn't. Does this mean that most published research is wrong? Our respondents don't think so. Most still trust published results in their field, with physicists and chemists the most confident. There are many reasons why researchers may fail to reproduce results. Sometimes a small difference like shaking or stirring a sample can lead to different outcomes. But the biggest reason, according to our survey, is selective reporting. Things like cherry-picking data to support a pet hypothesis. To get to grips with reproducibility, we need better mentorship, proper use of statistics, and more robust experimental design. All these approaches got ringing endorsements in our survey. Whether it's a crisis or not, right now lots of people are paying attention to reproducibility. That makes it a good time for everyone, funders, publishers, scientists, and the institutions they work for, to act. Read more and delve into the survey data at nature.com/news.
So we spend a lot of time on this channel talking about how powerful AI can or can't be. What we don't talk as much about is how we can consistently make good AI, or how hard it is to replicate algorithms that other people have developed. In fact, it turns out that in many cases we actually can't replicate the AI algorithms that other people have made, at least not using the instructions they gave us. Now, reproducibility crises aren't new to science, let alone artificial intelligence. I know from my personal experience in both my biological background but also in AI development that I've tried to recreate algorithms or methods from published papers and have run into a lot of trouble doing so. I'm doing this based on the papers they published, so in theory, following the methods that they outlined should get me there. Unfortunately, that's not usually the case. This is partially due to the writing issue, but also because there may be unseen factors in how the experiment was performed or how the algorithm was developed that even the authors might not be aware of. For example, if you're using a solution from company A and the person trying to replicate your work uses the same solution from company B, there may be slight differences in those solutions that cause their experiment to fail, whereas yours worked. This has actually happened in my lab before. But what about AI? Well, our reproducibility crisis is somewhat unique. I'll start by noting that there isn't actually very much peer-reviewed research that quantifies how bad this crisis is, so take that with a grain of salt. However, there are a lot of archive preprints and case studies focusing on attempting to recreate performance with specific algorithms. So while this may not be something that we've quantified for the entire field, there are quantifiable reproducibility issues with specific subfields of AI, like Facebook, Google, IBM, and those companies often don't release the original code that they used to get themselves there. This makes it difficult for any other lab to try to replicate the results. In fact, Facebook ran into this issue when they tried to recreate the algorithm AlphaZero, which was developed by Alphabet to play the game Go. In a paper that they posted on arXiv, they commented that the lack of source code, in addition to the considerable computational requirements, made it incredibly hard for them to match the results that Alphabet had shown, although they did eventually get there. And if a company that's spending hundreds of millions of dollars on developing this kind of technology has this much trouble doing it, it's basically impossible for any smaller academic lab or DIY developer. There's also the fact that AI is often referred to as a black box. We don't always know what's going on inside. Many AI conferences are beginning to require people submitting their research to fill out a reproducibility checklist. This checklist can include questions like, did you include your source code? How much money did you spend on the computational resources that you needed to achieve these results? If you ran your algorithm 10 times and took an average of the performance, does it still match the performance that you're reporting as your top score? NeurIPS, arguably the biggest AI conference, has a really comprehensive checklist for reporting. And while you don't have to address everything on the checklist, part of the score that your paper receives after it's been reviewed by peer experts includes how well you met the standards of reproducibility. In other words, your paper might not be published if you don't try to make it as reproducible as possible. We should also want to encourage the progress of verifiable science, because at some point, it will move out of the realm of academia and into our lives.
Every day AI. Hello.
Yeah, that's her channel. Everyday AI. So, I think both of those videos did a really good job of summing the issues that we want to cover today. Some of it I agree with, some of it I didn't, but it's presented and it should stimulate a healthy debate among researchers and engineers and practitioners. What I would like to have everybody contribute to whatever capacity they like is, as a professional or a researcher, what do you do as far as address reproducibility? Is reproducibility important to you in the area in which you work? And do you think it's a crisis? So, like I said, this is an open discussion, so anybody can chime in and talk about their experiences and what methods and tools they use. Do they think it's a problem, an issue? Cameron, why don't you start?
Oh, no. I think Jennifer, because she's probably the person that we see least often, right? And she's right in the middle of a PhD program, right? Or have you finished, or are you at the start? Have you done your thesis yet, Jen? We can't hear her.
Jennifer.
Still in the middle of it, haven't finished the dissertation, about to go into quals here.
Right. So you definitely have to deal with that reproducibility issue, right? Once you present whatever it is you present, it's going to have to be reproducible. So maybe you can share what your approach is. I hate to put you on the spot, but right.
So, not so much in my PhD right now because I haven't started actually doing research yet. I'm still I'm about to start that here. But in my master's, we actually had this thing called the Nist speaker recognition evaluation, and we tried submitting algorithms to that competition. And I think it's really important to have these kind of like Kaggle competitions and other similar competitions that have people submitting their algorithms to a publicly, be able to publicly evaluate them and have it be more transparent as to what exactly is going on and how, if you're because a lot of times when you see people publishing, they're saying, oh, my algorithm is 90% effective, and you're like, okay, that's great, but like 90% effective, and what are your metrics? What are
Right.
your error bounds?
Mhm.
So it's important to have open competitions, open data sets, open source hardware, software, and publish the data and maintain that so that other people can use it too, to say, I've reproduced the results, and here's also my results in comparison.
Right. I mean, it's one thing that the young lady in the video, she brought up something called leaderboards, right? It wasn't in this video. It was later on after what I showed. But she brought up leaderboards. And when I think about leaderboards, I think about video games. Video games have leaderboards. So I was like confused. What was she talking about? And so when I zoomed in on the screen capture that she had, it was, I'm trying to remember what it said. It was some data, it was a data bank for data for a particular area that had to do with how well the children learn. And so I guess the idea is people were submitting their algorithms, and it was showing the effectability of their algorithms as addressing that particular task with that particular data. And she was making a point that so many people want to be as high on that leaderboard as possible. So I'm saying that's how AI is working. That's ends up being a very important metric out there, to have these leaderboards, and you're high on the leaderboard as you're using your algorithms to address a particular issue and problem. And I said, this is the gamification of AI. Is this one of the ways that we're doing reproducibility, like based on what you're saying? It sounded like it was that idea of that competition and people showing, hey, this is how well my algorithm performed using this data. Have you heard of anything like that? It sounds like you're talking about something like that. Jennifer?
So, yeah, essentially, because the Nist speech recognition evaluation gives you a data set, and you're supposed to create an algorithm and demonstrate that you have a certain percentage or a certain efficacy in your algorithm. And I believe Kaggle competitions work in the same manner, although different things drive that one.
Yeah. Yeah, I thought that was very, very interesting. Like I said, I never heard of it before.
All right, but Kaggle, they were behind that effort that we were looking at for the COVID research. Remember?
Yes. Yes.
Did you get involved with that, Jen? For the data mining and machine learning for trying to see what we could see with respect to the COVID-19 virus?
Me personally, no. I wouldn't be surprised if other researchers at Los Alamos National Laboratory are.
Yeah. We joined that in a serious way. So we put our 2 cents in that whole thing. Are you familiar with the concept of computational notebooks?
Like the Python notebooks?
Yes. So do you use those? Do you subscribe to them?
I got recently introduced to them, and I think they're a great way to actually document as you go.
Right. And that at least affords some sense of reproducibility, in terms of any kind of conclusion you're going to get to that might involve a workflow or software and that kind of thing.
I mean, we're throwing that out there. Is everybody familiar with computational notebooks? Walter, John, Julie?
I remember we talked about it. I wrote it down and then I forgot to look it up.
Yeah, I looked them up the last time we talked, like the Jupyter books and things like that, and
Right.
looked into that. But, it's not something, I typically use because, that's not integrated to like the company I work for, our workflow to use that.
Right.
So, you know, we end up documenting more on like wiki type pages and stuff and doing it that way.
So,
Are they like lab books?
well,
Any-
this is software.
What, the computational notebooks?
Yes.
But are they equivalent to lab notebooks?
Yes, that's what they're trying to accomplish, that same thing. So if you are a scientist,
Right.
you record all your data, all your
Right.
processes, all your methods, all your algorithms, all your mistakes, all
Right.
your errors, everything. No, you're not allowed to remove pages from those
Right.
notebooks. You're not allowed to
Right.
write in pencil. You know, it is supposed to capture, you know, instantaneously everything relative to that experiment.
Isn't that a given that you do that?
Well, but you'd be surprised how many people aren't.
Yeah, well, I know that because I remember I used to teach my students to do that all the time and never get rid of any kind of code.
Right.
You know, you can always cross it out just like you do in a lab notebook, but it's always available if you need it.
But in the digital world, right? We have cut,
Yes.
copy, paste, delete,
Yes.
rename, remove, move. And so how do you accomplish that same?
Well, you got to be patient and do things slowly, and nobody wants to do that.
Right. And
Another tool that you could be using for that is software control or software version control, like Git.
yes.
Isn't there? I haven't been coding or anything lately, but the latest versions, let's say like a C++ or Python, is there any mechanism built into it where it records all this stuff all the time? You know, where you remove code, add code, etc. So it's always there for you.
Well, you have to have, yeah, that's what Jen was just bringing up, a source code management software.
Right.
But the software development effort is actually way bigger than just the code, right?
Right.
You got all of those design phases and you
Right.
testing phases, and let's not forget meetings, where you have end user meetings and management meetings. If you're going to truly document
Mhm.
the entire process, you got to have some tool that comprehensively lets you deal with the entire software development lifecycle.
Exactly.
And if you deal with that, you know, another aspect is you have to wonder like what environment are you running these things on? Like, you know, there's this code that you wrote, but you need like a total snapshot of all of your dependencies, right? You need a total snapshot of the environment you ran it in.
Yeah.
And depending on what you're relying on, like if you're doing like GPU computations or something like that, you may need to annotate, you know, which hardware you're running on and which firmware versions they're running on. So there's a whole litany of things you have to keep track of if you want it to be reproducible.
That's exactly true, Julie. You're right. I have a diagram that I'm going to put up in a little bit that just really speaks to all that. I'm curious, Walter, though.
Yes.
You were a big part of, and still are, I think, IEEE, right? What is, you know, from an engineering point of view, did they have a certain set of tools or processes or anything that would reinforce the concept of, you know, repeatability or reproducibility?
Well, I don't know exactly what they do because I'm there primarily through computer science and not electrical engineering, but I would imagine they have to keep track of all that stuff.
Yeah.
They have to.
But the problem is if the two videos that we put up, if you were to just dig around the internet, you would find hundreds of videos like that, and it seems to be a crisis, you know, I mean, a significant crisis, at least in the United States, in all areas. And we're talking about engineering, physics, chemistry, biology. So there is something fundamentally going wrong, you know, and it's not that people are just being dishonest. For some, you know, there's just, look at the, you know, I guess I would point you guys to some of the stuff that's out there. Look at the percentages of scientists and engineers that have a problem with our reproducibility, at least in the United States. I can't speak for other countries.
Oh, I think it's true around the world, but you know, I personally think people don't like to be detail oriented.
Wow.
You know, because that requires a lot of work and thinking, and they don't want to do it.
Yeah. But
You know,
does safety concerns come in there if you can't reproduce something?
well,
Aren't
yes, that happens all the time. You know, I've read so many times about chemistry or biology or medical experiments. You know, they publish it, it's wonderful, they get all kinds of prizes, and then nobody can reproduce it.
yeah.
I think there's also the problem of this isn't something that it's not something that's hot. It's not something that gets a lot of money or a lot of attention. Like we can say it'd be nice to actually do reproducibility, but if there's no money and no real push to do it, then I guess it won't be done because we're all chasing grant money
There you go.
elsewhere.
She said it, grant money.
Yes, and then everything needs to be done overnight.
Right. So I mean, I looked at a number of these the videos that Cameron was looking at, and it's rather frightening. So it was some physics experiment, and I wish I would have wrote down the nature of this physics experiment. And the results were really great, and people were really happy about it. And then they was trying to reproduce it. People couldn't reproduce it. Ultimately, they found out that it was some hardware issue. The reason why it was this showing of this result was there, it was because of what someone did with some hardware. It was some patch cord. It was really weird.
And it was done afterwards?
Yeah, it was the reason why this result was produced was someone making some error in connecting some patch cord and it got this result.
Right.
And the reason why people couldn't reproduce it is because it was really an error.
Right.
It wasn't something that was supposed to happen. So you get really concerned about it's not just I mean, some of the issues that we're bringing up. Okay, we could talk about publication is one of the things that I saw as far as certain journals that end up publishing things from particular people or particular group, or maybe their data was too small, or maybe everybody's using the same data. They get some. It wasn't so much that. It ends up being just the nature of the work that they're doing. It's the nature of it that you end up with just creating these errors, and it's not even just a colleague trying to reproduce what you're doing. It's you're not being able to do it either. So then you do it, and then you're not testing enough, you're not verifying enough, you're not repeating enough, you're not examining your process enough, and then you go out there and say, look at my results.
Right.
So it has a lot to do with how we're doing the science and how we're doing our work, and what are the tools that we're using, what are the methods that we're using to design software, to test software. What are we doing? Like I said, it's not just the outward looking at a colleague. It's what are our processes?
Our culture. Hey, John, John, are you still on? JD.
He's gone.
Well, his name is still on here.
Sorry.
There he is.
Hey, John, do you remember the Jakarta project at YSU?
Vaguely.
And do you remember that the decision that we made to purchase that Jakarta, a last part of it was we were sitting in the conference room, and there was another university that vouched for the software. And you know, they basically did a demonstration, and they told us that it would work a certain way and scale to a certain number of students. Were you there for that?
I don't remember that.
Yeah. Well, I was there. This was a case, I think it was Georgetown or some university like that. And YSU was
Okay.
getting ready to buy a sizable piece of software that would help with student registration and help bring the mainframe technology to a web-based technology. So they purchased this software on the word of another university that said, hey, we've installed it and it works just fine. YSU goes out, we spend, I don't know how much money on this software. And when we get it, we can't make it work. We can't get it to scale up to the number of students that YSU is registering. And then when we contacted the university that we got it from, it turns out that the CIO of that university had just gotten bad information from the tech people. The tech person had exaggerated the whole thing. They were unable to actually make it scale at that university. So here we are in a situation where hundreds of thousands, I don't know, maybe a couple $1 million may have been spent to buy this software. And we had someone vouch for the software that couldn't even get it to work in their organization and institute. And so that's like an example at an application level.
Didn't they have somebody come in and tailor make it for YSU?
Yes, that what ended up happening was they, because they could not replicate the performance of this other institution, YSU, on top of paying for the software, had to bring a consultant from Israel to YSU for I don't know how many weeks, trying to scale and load balance this software, and it was just a nightmare. And they were the company that actually built the software, and they couldn't get the results that they had claimed, which kind of leads me, can we put this diagram up? Kind of leads me to a point. I think that a lot of the problem with science, engineering, chemistry, biology, I think it's the computer people's fault. And I actually want to blame the computer science folks, right? Is there a way to put that up?
Hey, Julie, it's a diagram Cameron wants to show.
Okay, well, there's a couple ways to do it. I could stop sharing and let you share.
Okay.
Give me a sec.
And maybe that'll make, okay, so you know where it is. Let's see. That's right there.
Okay, you should be able to share now.
Okay.
So where's the share?
I don't see the, oh, here it is.
Can you all see that?
Yes.
Yes.
It's kind of a color-coded thing. I've got these blue boxes are kind of like artifacts. When you talk about the scientific mathematical models, that stuff is fairly standardized. We have certain math, we have certain procedures, we have certain processes, but there is an engineering gap. And Jennifer kind of mentioned it a little bit. There's an engineering gap between an algorithm and actually implementing that algorithm. Okay, the algorithm and the math and the method, that's one thing on paper or electronically. It's another thing to implement that in some form, to actually materialize it. And it requires a certain amount of engineering there, even at the experiment level. And my conjecture, my hypothesis is that the software, a tool set, the software, hardware and software that people are using in all of these fields to get to the experiments, that software and hardware is the weak point. It's one of the failure points. I have this, if you see the diamond shape that says features, convenience, compatibility, and cost, a lot of the software tools and hardware tools people are using, it's very version driven. So organizations, labs, students, everybody is chasing versions. A version XYZ of the software, I'm using RapidMiner 1.2 or RapidMiner 1.2.3.5, or, some data mining software that runs under the Mac. Well, I have the Linux version. Well, no, I have the Windows version. Well, I did mine's on an iPad. Well, no, I did mine's on an Android. And so you have hardware, software version issues that's intervening between the mathematical models and the scientific models. And then on top of that, the scientists, the physicists, the chemists, the engineers, those people are supported by IT people. We're all IT people in one way or another. And all of us, we all have different degrees. There's no standardized degree process. Our curriculums all look different. Our testing all look different. I would venture to say that not everybody here has the same understanding of the UML or system flowcharts or program flowcharts or ERD diagrams. I would venture to say that we'd have a multiplicity of interpretations for that. We don't have any licensing, software licensing in our field that's national or international. And so what you end up having is the thing that supports the scientific and mathematical enterprise. The thing that supports that is IT, and IT is basically non-standard and it's version driven. And if you go down, the scientists, the researchers, they produce the experiments, the papers, and the publications. And then you get businesses, large IBMs, whoever, Google's, down to the mid-sized businesses. They basically take those results and then they implement those things into applications and products. And there's an engineering gap between a paper, a publication, and an actual application that you're going to sell, a good, a service, a product. And that engineering gap is also something that suffers from software and hardware features, in versions, right? And then at the bottom, I have this note that says engineering gaps are often controlled by profit, competitive advantage, office politics, and personalities. I am putting this diagram up really as a result of maybe 20 years of experience of working with scientists, engineers, business people, and I've really seen this firsthand. You don't think that the software tool set and the software process is responsible. It might not seem like it from the external point of view, but I've seen it really be behind a lot of problems in organizations that you wouldn't believe. Some groups are Linux groups, some groups are Mac groups, some groups are Windows groups. Somebody is using RapidMiner, somebody is using Wicca, somebody is using Rust, somebody is using C++. Somebody is going to use C++ 14, somebody is using C++ 11, right? Somebody is using Linux kernel 2.65, somebody else is using 2. All of those version differences, the process differences, the fact that we don't have a standard software development lifecycle, all of that stuff has a major impact on the scientific enterprise, and then it also has an impact on the government. So, government and business applications. So I really want to blame the computer people. I want to say that beyond making some mistake at the research level, or at the engineering level, I want to say it's the lack of standardization, the lack of specific standardized processes and metrics in the computer science and IT fields that's really messing the whole world up. I really want to blame us and say that if we were to get our act together, that the reproducibility and replication process would be dramatically impacted to the positive. And I really believe that. I tried for months actually to really come up with another intersection that touched all of those fields besides hardware and software. And I want you guys to challenge me over the next, I don't know, maybe 6 months, if you can show me that I'm just dirt wrong before I go ahead and publish this in some major journal, right? And tell me why I'm wrong. But I think that if you guys know anything about how software tools and processes are selected for a laboratory.
Right.
You know, people's personal pet peeves are chosen, or someone's budget dictates what's going to go on, or hey, some director is best friends with another director, and that director likes to use the Macintosh whatever software, and so they do it like that. And then next thing you know, the researchers, the students, the engineers, the programmers, they're all just using, you know, tools for reasons other than those tools are the right thing for the job. You know, at YSU, we chose this tool simply because another university said it worked, and we really didn't have any proof. I saw the selection process for software in the state of Ohio be so political. Maybe 10 times. We're talking millions of software that would literally affect hundreds of thousands of students throughout the state of Ohio. And it was just chosen on the most political and whimsical and pet peeve kind of a basis. And this stuff becomes the foundations for experiments. You know, just an example at YSU, the scientists at YSU, the researchers at YSU, they are subject to the IT platform that's in place. It's not like they can bring their own computers there. They can't bring their own software there. Jen, how does Los Alamos allow you just to bring any kind of thing into there and connect it to the computers and load whatever software you want?
Absolutely not. That is a security issue.
Right. And so if the IT security says it's a no-go, it doesn't matter how much more correct or how much more appropriate it is for what you're doing. They're really running the show, right? That they can dictate what computers are in place and what software you even allowed to use. Right. And so and if they have some kind of like I'm using YSU because they're so convenient. The security guy there,
right?
He is a Windows guy, and for him, all he wanted the university to do was switch away from Linux and away from Unix to Windows-based technology. And he won, I think. You know, won large parts of that argument.
Do they? Is software engineering still being taught?
It's so watered down, and it's so driven by business concerns that the business community gets to define what software engineering is. Like the whole agile process, you know, that is not something that came out of academia and the engineering school. It's simply not. You know, if you guys do the history on that, that comes from somewhere else, and that was really superimposed on top of a lot of computer science and IT curriculums, at least in the United States. And so we have agile as really some kind of process that's you know, being used as a standard, and it's just totally lacking, totally. And it permeates everything. They're talking about agile in chemistry experiments, using agile for synthetic chemistry, and it's crazy. And that all stuff is being driven by business. And so the profit motive, competitive advantage, it's amazing how much that stuff is dictating what software and hardware we use. And then if you throw security in there, well, that's it. Once you bring up security, everyone else has to just shut up, right? Is that correct, Jen? Security people dictate terms. They get to say, if it's not secure, you can't use it. And if they have certified it as secure, you better use it, whether it's the right tool for the job or not.
I remember all the excitement when they started doing this agile programming.
Right.
But the other thing that I'm interested in, does anybody still do extreme programming?
Yeah. I
didn't think so.
Oh, I think it's still out there.
Still out there, man. And some people equivocate extreme programming with agile. Yeah, they put them in the same bucket.
Yeah, but you know, with extreme programming being quick and dirty, as they called it, you know, you're not always going to get a good product.
Right. And how is that different from agile?
Yeah, that's what I mean. Because agile was the big thing after extreme programming.
Right.
So is it a matter of better documentation? I mean, I need to document all the way down to the hardware, the version, the software, what version I use, et cetera. I mean, with those computational notebooks, you have to include your whole environment that you use in order to produce that result.
Right.
And that was what when we were looking at the whole COVID-19 and wanting to make our contribution. That's how you made your contribution, is you had to create that computational notebook that's going to explicitly show and include everything you need in order to produce that result.
Right.
So is it just a matter of better documentation and creating that environment and under which that those results were produced?
Right.
And then we could all go home. That's
right.
the bottom
Well, you know,
we could go home.
And
use computational notebooks.
In the last capstone, I did a capstone class in 2019, I think, or 2018, and we looked at software development lifecycle methods. And here's one of my big criticisms as a professional in this field for a lot of years. We don't have quality documentation for the design process, right? We talk about documenting code and documenting certain kinds of tests, but long before you get to coding, right, you have a preliminary design and a detailed design process, and we all basically have no real good tools for that, right? I should be able to design the software just at the design level and present that design to the end user and have the end user totally understand what they're looking at and be happy with that design and be satisfied that that design solves some problem they have before I actually built the software. I mean, if you look at like in the engineering and the, let's say, architectural kind of field, they will build models of bridges and buildings, et cetera, and they bring the end user in to look at it. Hey, does this work? You know, does this, and they are able to go from there. We don't have an equivalent kind of thing like that in the software engineering. We tend to.
You could create prototypes.
That's the whole point. That's the whole point. And in the rapid prototyping, in order for it to be effective, that rapid prototyping can't just be a quick and dirty interface. It's got to be a rapid prototype that can fit in the context of the application that it's going to fit into. And that's where we really fall down. So things like the specification and the requirements phase, we do not have good design tools to capture those. Don't have good design tools to capture the design phase. And we certainly don't have tools that are standard enough so that I could send Julie a design of software that I am a system that I'm working on, and that she can understand what that design was. And she could see it and evaluate it and critique it and then send it back to me.
So
we don't have anything.
We're talking about standardizing on tools and then have an educational system in which everyone utilize those tools and everyone is able to understand it.
Part of the problem is also that the end user has to be educated.
Right.
About what needs to be done, because they'll tell you, oh yeah, that's what I want.
Right.
And then you produce the product for them. Well, that's not exactly what I want.
Right. But when you, that's the key, Walter. When you go to, when technical people, and I'm speaking specifically about people who develop software, and I'm including websites and those kind of things in this category. When those folks go to the end user and they show them something, right? What are they showing? Having a conversation is not sufficient, right? Showing them a diagram also is not sufficient. And showing them simply a user interface. This is what it's going to look like. That's also not sufficient.
Right.
Because I can't tell from a user interface how it's going to work and interact in my business. And so that's where the agile people kind of have a point. What they try to do is give the end user something working that they can work with as quickly as possible and put their fingers on and try it and test it out.
Mhm.
And the problem with that approach is they leave that thing that really is a prototype, they turn that thing into the production software. And
Mhm.
they let it run their businesses or the organization or whatever it is. And that thing should just be something that gets the end user to approve a design,
Mhm.
not to function as the actual product, right? So Agile wants to combine the product delivery and design delivery in one single step, right? You can't do that. All other engineering and scientific fields, they have a design phase where you design an experiment, you design a product, you design a service. When we're bringing up documentation, we don't have simulation tools. We need simulation tools that would allow us to simulate how a software design would interact with a business process. And we don't have tools, or at least we don't have robust tools that do that. And so if I were going to make a major contribution to computer science or software engineering, it would be simulation design tools where I can come up with a rapid prototype that can be put into the application context and convince the user, whoever they are, that this thing will work to solve your problem. And then once you sign off on that, then we begin to develop the actual code and the documentation process with that. And
Right.
the Agile process, what it wants to do is go straight to production.
Right.
It doesn't want to give any room for any real design process or documenting a design process or anything like that. And in addition to that, you have to have something that documents the end user, the meetings. Those meetings, and where you're think taking and brainstorming, you've got to have those meetings be a part of the design documentation.
Right.
And we have no set of standard tools or of integrating that, of searching it. Once how do you search through a brainstorming session? How do you put your hands on a brainstorming session that we had 2 years ago for some project? We just don't have design tools to deal with that. And I really, in my heart of hearts right now, believe that is one of the major weak points for the experiments, papers, and publications. And I'm saying that because I don't think there is any science going on right now anywhere that does not utilize and depend on computer technology.
Could I interject a couple thoughts?
Yes, please.
Sure. One, to circle back about this diagram that you showed and all these things, you have to realize that maybe some of the people who are doing these experiments are not necessarily computer sciencey people or necessarily IT savvy people.
Exactly.
Right? So for them, they resort to a systems type model, right? It's a black box. This thing does a thing. I give it an input, I get an output, right? So for them, they're worried about those inputs and outputs, and they're assuming the system, because in their mind they can't understand it, right? So they just treat it as a system.
Right.
So I think you're right that there's definitely some more that we need to consider on that to make that reproducible, right? Because if you had to know all of this stuff just to get something done, that might be hard for people to make progress.
Right.
Now, given that, it's really important for reproducibility, which is my second point, is that, not only is, and I think that's something we should talk about is why is reproducibility important, right? And in this case, one, just because you can reproduce the result doesn't necessarily make it true, right? Right? But you need to be able to reproduce it, right? Like person A performed an experiment and they got result B, right? So person A and then person D tries to do the result and they get result F, right?
Right.
But or maybe they, so did they do it wrong, or was their result the real result, right? You don't know, but let's just say that person F did it and they got the same result as the first person, right? Now we have something to talk about because now I have that system in place, right? I knew the steps, I can reproduce it. Now I can analyze that and say, is that a valid result, or is there something wrong with the experiment, right? But now that we both have the same result and we're both reproducing it, now we have a basis for that scientific inquiry, right? Whereas before, you're just saying, I got results, and if no one can reproduce it, that's not helpful, right? We can't have a dialogue and we can't have meaningful critique on science or technology if it's not reproducible, because we've all seen all kinds of experiments that were flawed, right? But if you tout it as being valid, and even if everybody can reproduce it, but if the experiment's flawed, it's still an invalid result. I mean,
that's right. You know, Julie, to your point, we've interacted with several chemists, several physicists, in the context of doing their work, right? And here's what you get. The chemists and the physicists feel like this. Well, they feel that if they have to hire, let's say, say for instance, they have to hire Jen. Jen is she's a doctoral student, and so she's going to go work with some physicist, right? Well, the physicist wants Jen to really have real serious physics knowledge, and they feel like, well, it'll be pretty easy to teach her the computer stuff, right? Or I want her to know the chemistry, and it'll be pretty easy to teach her the computer stuff. And so I've heard that I don't know how many times, and the physicists and the chemists and the biologists themselves, here's what they do. They will actually, in the middle of doing an experiment, feel like, well, okay, I'm going to learn Linux and I'm going to do my own programming. How hard can it be, right? And so there is a disrespect for the knowledge base that's required for a computer science major in the other fields of science, right? They feel like just as an afterthought, they can deploy the technology in the context of their physics or the chemistry or their biology. So you were saying that they look at it as a black box. That is absolutely correct. But many of them go beyond that. They feel like, their britches are big enough to just code themselves when they need to, or load Linux when they need to, or they can pick tool sets. They know whether they should be using Python versus some other thing. They feel like, the whole notion of a computer programming and all that is really no different than picking a cell phone, right? And that goes back to the fact that our field does not have a standard in terms of knowledge. We don't have licensing, right? If you needed to have an engineering license, software engineering license to do any kind of software, that would change things, right? If there was a certain standard of education that you needed to before you could load Linux, that would change things. But it's not. It's perceived as something that your 12-year-old nephew could do, and so therefore you can get in your lab and do it. Do you guys know what CRISPR is?
Yes.
You've heard of that?
Yeah.
How many different software platforms implement that algorithm or set of algorithms?
I don't know.
Right. How many different versions are we dealing with? How many versions of Windows, can you get it to run on? How many versions of Mac? How many versions of Linux, right? Which one does a given scientist use? And why do they use it? It's going to be very flimsy, whimsical. As a matter of fact, this is what I'm comfortable with using it. And same thing with all of the data mining tools out there. Yes, you're absolutely right, Julie. It is a black box, but which black box do they pick? And why do they pick that black box? And what kind of software and hardware ecosystem comes attached to that black box, right? This software just doesn't run in a vacuum, right? And so once you pick a piece of software, there's a whole bunch of other software that goes with it that you're going to, there's a whole paradigm that goes with that. And those paradigms are really selected willy-nilly. And it is the most simplistic kind of choices go beyond, are behind picking one platform over another platform. And I'm really proposing that choice, that use, that interface to the software ultimately trickles down into these experiments, because all of these experiments are things that are being run on software platforms and in software applications and on certain hardware.
I mean, if the nature of what we're doing is supposed to be scientific, it's disturbing to think that I could do some calculation on one calculator and do it on another calculator to get another answer. So it's like, what's going on?
Well, 16-bit versus 32-bit.
Yeah, I mean, but what I'm doing is supposed to be science, and it's supposed to be true or work or not work and not have anything to do with the technology.
Yeah.
So why is it that the technology ends up affecting my results? I mean, what are we really doing and producing, in which it depends on a platform or software or version that I'll end up getting?
Well, that's my point. See to the left. I guess that's to the left. That's to my left. Everybody's left. Those diagrams, I guess. Right. Because our degrees, IT and computer science degrees, are non-standard, there is no agreement on what we're actually producing. And so, what is a legitimate result in a Microsoft environment might not be a legitimate result in a Linux environment, because we came up in different schools. We don't, how many people.
And that has to do with our process.
That's right.
Our process.
And those processes
before it gets to the technology.
And those processes are standardized. That's what I'm saying, right? ANSI, ISO, international standards don't mean anything to software people. Jen, we're picking on you here because you're the only doctoral student that we have in the panel. How often do you look up what an ISO or ANSI standard is, or international standard is, for some piece of software that you're getting ready to use?
Oof.
Yeah, right. That's probably it's not a consideration for most. Julie, in the course of your work, do you actually care about what the ANSI and ISO or IEEE standards say for XYZ?
Typically what I care is that when especially if I'm dealing with, any kind of cross-system interchange, one, does it work? Two, did it mess it up?
Yeah, that's right.
And no, we're not looking up standards usually, but we definitely rely on them, but we're not looking them up, and we're not trying to implement things to certain standards.
Right, but I bet you if you were in a physics lab or a chemistry lab or a biology lab, there are all kinds of standards that you would be very much aware of every day, all day long. But something about the mathematics in computer science, we don't feel that it needs to be standardized and everybody can kind of roll their own and don't make a big deal out of it. And that attitude right there is the part of a large part of the reproducibility crisis. That's my anecdotal, personal experience with a couple of chemistry and physics teachers, researchers, and some engineers. I've just experienced this firsthand. It sounds so innocent, well, I'm on an iPad 2 and you're on an iPad 1, or I'm using Android, or I'm using CRISPR 2.0, or whatever it is. That sounds so innocent, but at the end of the day, those choices bring with them entire ecosystems. They bring cultures. There's philosophies, there's user interfaces. There's so many things behind those things that impact your experiment, your paper, your publication, the application that you're going to deliver to the public, so that if you have variances at that level, of course, it's not going to be reproducible. Because you guys said it early on, if someone uses different hardware, it's going to be an issue. If I use different versions of Linux, or different versions of ChemTool, or MATLAB, right? Somebody's gonna be a MATLAB culture, and somebody else is gonna be Mathematica, right? You run into that, Jennifer. So there are people that are, they're groupies for MATLAB, and they won't use some other tool, right? And I might be a groupie in the Mathematica world, and I won't use MATLAB tools, right? I might be a Python person, or somebody else has decided I'm going to use Rust, and that's all I'm going to right? And the ecosystem that comes with Rust or Python. Those kind of things will impact your ability to reproduce someone else's algorithm in a big time way. And I think that goes up and down the chain of stuff. And I really want to, at some point, throw this out as a challenge to the IEEE and ACM. So you guys, please, over the next weeks, months, or a year, when you get a chance to think about this and realize that I'm dead wrong, just send me the email so I won't embarrass myself, presenting this as the major reason why we have reproducibility issue in a crisis in the United States.
So
because I would have submitted it as a hypothesis.
So in HPC, for example, just for reproducibility and comparison purposes, if you need to know what hardware you're running, what version of software and what compilers, and you state that in your publication.
Right.
Simply because you have some random piece of code going faster is kind of meaningless unless you state the hardware, state the software in significant detail.
That's right. And what's the resolution on that? Okay, when I say hardware, right? What's the resolution? Does it just have to be the processor, or do I have to also specify the drive types and the speed on the drives and the network communications and the Bluetooth, the drivers? Because I could have the same operating system and the same hardware, and the drivers all be different. Well, what happens there, right? Right now, Tracy and I are doing a lot of, we have not left the robotics thing. And so our robot right now consists of 4 or 5 Arduino processors talking to Raspberry Pi. And we're doing Bluetooth communications, serial port communications, and I2C communications over that. And I am telling you now that depending on what drivers or how we approach those protocols, you will get different results. In the operating system environment and the hardware environment not change. And so even when you go to the extent of, well, I'm going to list what version of operating system and what version of hardware, if we're really going to talk about real reproducibility, you got to have maximum resolution on that, right? We got to talk about versions of the motherboard. Which chip, which processors are you using? Which year was those? Were they done? Are these Intel Core 9s done from 2018, or were they done in the second half of 2017? That kind of stuff makes a difference. I mean, especially when you're talking about things where one electron could change the result. It's a big deal. And the computer science folks, we haven't even begun to really truly understand what it means to have a standard and an environment that we can enumerate, right? And when I look at the problem, I don't want to beat a dead horse, but we've been thinking about this and talking about this now for at least Tracy and I and folks that we interact with for over a year, in a very, I guess in a saturated kind of way. And every time I look at the problem behind, there are 2 things. It's the shabbiness of IT and computer science combined with greed and profit of capitalism. You take those 2 things and you put it together, and you have cheating scientists, right? You have people that are hustling, trying to get grants. You have experimental results that aren't reproducible. I don't know. I'm making us the bad guys here. But anyway, I've
go a little too far on that.
Yeah,
I just want to. I know we're getting close to the end. I do have a question to ask you, Jen, and I'm sorry I'm picking on you, as well.
Yeah.
It's a guy, Bob Paddock. He's a part of our group, and he couldn't be a part of our discussion today. But what he does at his job is he builds sensors, and one of the things that he said that they have an issue with reproducibility all the time.
Right.
And it said that they have a standards issue as well. And he said they're always being audited by ISO and audited and they have to do ISO 9000.
That's ISO.
ISO 9000 audits, and he didn't say what those were. Are you familiar with that idea? I wasn't sure what ISO 9000 audit is in relation to building sensors and manufacturing sensors.
So the ISO 9000 family
Right.
is a quality management system, like a set of standards that helps organizations ensure they meet customer and stakeholder needs within some like statutory or regulatory requirements for some product or service. And I think this kind of comes into like software quality and management in large companies, because I've heard ISO 9000, I've heard CMMI level qualifications for it too.
Right. And the ISO 9000 is a huge set of standards, many hundreds of standards with thousands of things that you look at. So you know, for you to be an ISO 9000 compliant organization, that's a huge undertaking. You know,
it is, yes. There's many people involved in actually making that happen.
Yeah. You could be looking at something that might take months to do the audit, you know, depending on the size of your organization. Yeah.
Okay, because he was complaining that they're not very good at reproducibility.
Right.
So they're getting these audits done, but he's always talking about testing and rigorous testing, and they don't do a good job.
Oh yeah. So listen, here's a point, guys, before we go. Standards are necessary, but they aren't sufficient, right? You can't look at it, well, just because we've met the standard, that's, you know, we stop there. Standards are the bare minimum that you need to have in place. That's a floor that we should all start from. Mm-hmm. So you can be ISO 9000 compliant and still be putting out crap. It just means we can understand the crap that you're putting out. That's all that means. That's kind of the point that Julie said, well, just because it's reproducible don't mean it's correct. You can be very good at reproducing.
Saying it could meet a standard, right? And it could still be crap.
Right. Like for instance, I could have a program that is ISO C++ compliant and meets the ISO standards, and my program could absolutely produce wrong answers every day.
I can tell you.
I don't think the standards are going for accuracy or anything like that.
We're just using the same thing, whatever that thing is. We've agreed upon that a wall socket is going to have these two, you know, going to have a ground in it. We've just agreed on that fact, and that doesn't necessarily solve all of the problems. They give you a common language to speak. And what I'm saying right now is the IT people, we don't have a common language.
Okay, but that doesn't lead to me using that wall socket and not getting electrocuted. Yeah.
Now, once we've agreed that all wall sockets are going to have a ground, then the people who manufacture wall sockets, they know what to build their product around, and that is where the safety part comes in.
Okay, but it does lead to safety.
It can lead to safety.
It can lead to safety.
It doesn't necessarily lead to safety. But if you don't have the standards in place, it's very hard to achieve the safety. Okay. Because you don't know what you're doing.
So standards are an important milestone to have in place and meet on the way to reproducibility and replication.
They're necessary but not sufficient. Right. So the standards alone won't solve it. But we're in a situation where we don't have standards. We don't have a standard software development lifecycle. You know, Julie develops software as she please. You develop software as you please. You know, Jen develops software as she please. All of you guys.
Part of this discussion is to determine what people are actually doing and implementing.
Right.
So we do have standards. We do have all kind of tools and methods and metrics out there. Are we utilizing?
Those aren't standards.
I'm making a
Oh,
general
okay, I see what you're
statement.
saying, yeah.
We have standards.
Right.
We have things that's produced by IEEE ACM.
Yeah.
We do have a standard curriculum for computer science
Yeah.
and IT and engineering. We do have licensing that exists out there for engineers. We do have all kind of methods for software design
there is no
and
record. There is no
testing.
recognized software engineer national. There's no recognized software engineering a license. There is not. And Julie answered the question about the standards. She first worries, is it going to work? And if I was in her place, that would be the first thing I'm asking. Is it going to mess something up? Right? That's a big thing, because ultimately you don't want to get fired. You have a manager that wants you to get things done expeditiously. Right? And a lot of times you looking up ISO 9000 or ISO or IEEE standards, that's not really helping you be all that productive. And then if you find out that the tools you're using are not ISO compliant, right? Or ISO compliant, you're not going to go to your manager and say, hey, we need to spend another $250,000 to get XYZ tools. Are you, Julie? Right? Can you imagine doing that PowerPoint presentation where you go to your management and tell them, you need to switch out the tools you're using to get these other tools for about $1.5 million that is going to, only difference it's going to do is make you ISO compliant?
Might be a hard sell in the industry I'm in.
Yeah, right. It's a hard sell in every industry, right? And even if you were putting a Mars rover up on the, if you're putting a robot up on the moon, on Mars, you still have to beg the NSF for that funding, or whoever's funding you, the government, for that funding, and you've got to justify, you got to do a budget justification for every little thing. And they're going to ask you, do you need to have this $1.5 million?
Well, in ending this very interesting discussion, and maybe we should do part 2 later on in 2021. I'm hoping there are a lot of standards and reproducibility related to any kind of immunization and vaccination that's going to go on related to COVID-19.
Right.
Hopefully they won't have those kind of issues.
Right. Well, when they say that it's 98% effective, it's based off, like Jen said, your algorithm is 90% based off of what? What metrics did you use?
That's why statistics are important. And another thing that I think hasn't been covered yet is these shared computing resources are available, and using those, like IBM's Quantum Experience, which is an online platform that gives users and general public a set of IBM's prototype quantum processors via the cloud, or like Google Cloud, which gives public users access to GPUs on the cloud, just to make sure that we have some like standard hardware that we're actually using to test our algorithms.
That's right. But here's the thing. This is a snag I'll throw in. Let's say, for instance, we're using AWS, right? We're using AWS things. We're using Google libraries, and we're using IBM their cloud resources, right? And let's say we did XYZ research on that thing, and let's say the cybersecurity at Los Alamos finds some security holes in the AWS and in the IBM offerings, right? The IBM folks will then, and the Amazon folks will then update those libraries to address those security concerns, we hope, right? And so then they make all that available to the public, right? Well, what do the people do that had the previous version? And they've got, 4 or 5 years tied to a previous version of the AWS and a previous version of the cloud, right? Now we got we have some scientists on version 1 and some scientists on version 2. And the big difference between version 1 and 2 was there was a security problem, right? And so you have an issue with versioning, that not everybody can switch to the next version at the same time. And it's for all kind of reasons. Sometimes it's cost, sometimes it's culture. We've got, that's a challenge. It is a big challenge. And IBM may decide, well, Google may decide to update their entire offering because Amazon has just done something that is more competitive, right? And so they're gaining more market share. And so Google may decide, well, you know what? We're going to update our Google Cloud to offer these new set of features. Well, what's going to happen to all of those researchers that are depending on the previous version of Google Cloud, right? Because in order for you to know that Google Cloud 2.0 is actually backwardly compatible with Google Cloud 1.0, one hell of a lot of regression tests are going to have to be ran globally on countless number of experiments, right? So there's just an issue. There's a significant issue. Even with shared research, that helps, right? Computational notebooks help. The shared resources help. Open source helps. Standards help. But beyond those, I think we've got to recognize explicitly that computer technology and software is an explicit weak point in all of this, and not just kind of recognize it. You know, they kind of recognize it, right? But are they really saying, hey, you know what? This thing right here is killing us, right? These different versions and these different cultures, software cultures, and these different ecosystems that are not compatible, the different versions, they're very brittle, all of that stuff, and we're building our science and engineering on top of all that. So anyway, we can pursue this for another day. Guys, please think about some of the stuff, at least that I put out there. Be prepared to tell me that I absolutely have no idea what I'm talking about over the next 6 months or so. And I would appreciate the feedback from email.
All right, thanks.
Okay, so we're going to end this, and I would like to thank everyone that logged on and participated.
There's Tom Atwood.
Yeah, I see that. I was sitting here.
Yeah, I'm here.
Hey, how you doing, Tom?
You missed the good part, Tom.
I got a couple of questions to ask. If I can slip something in the last minute before we adjourn.
Sure.
I think there's, you know, I can look at this from a journalist's point of view or from a lawyer's point of view, but I'm not a programmer. But from a logical point of view, there's something slippery about the premise. With all these different competing ecosystems of software and hardware, you know, that are just blooming all around us, I don't know whether the premise of common standards that encompasses all of them, that I'm not sure that's practical in dealing with that variety, that efflorescence of different ecosystems of hardware and software systems. So, you know, I'm concerned about the premise itself. It may be unrealistic, is what I'm trying to say, to expect common systems and unavoidable in the natural evolution of things.
Right.
Okay, so that's just a philosophic position.
But that's a correct point. It is very impractical, very impractical. Impractical from the point of view that the cost that will be involved, right? So there's no mistake about that. And nature is full of trial and error of trying to connect systems over millions of years, and all of the you know, that's a reality. But there's a lot of death, damage, and destruction done in nature through trial and error, trying to connect these unconnected systems. And we have a situation where the entire world, our human infrastructure, is being built on inconsistent, incompatible, ever-changing versions of software. And so you have to decide from a practicability point of view of what's the greater cost.
Okay, well, I mean, I agree. I think you've summed that up very well, but I think there's some hope in very specific contexts, which is my second point.
Yes.
Which I think, you know, I don't know why people in highly specific contexts dealing with software and or hardware,
yes,
whether they can't use any one of the handful of excellent time management programs that are out there. You know, they document steps in an expandable horizontal graphic to which exhibits can be attached. You know,
yeah, but is your time management software using Greenwich Mean Time or Eastern Daily Standard Time? Is it the metric system, the standard system?
Well, I correspond with people all around the world, and I deal with the time zones and the language accordingly.
Yeah, I do too. And you know how many times I show up at the wrong time? in the wrong place. Right.
No, I'm just saying that there's time management programs that are tools that can be that can be applied to in specific instances to get a handle on the design challenges that programmers face.
And
You
Tom,
know,
facetiously, I'm begging your question by asking which one of those time management tools should I use and which version should I pick?
well, we'd have to go offline and talk about that. I've looked at a couple of them and got a headache, but you know, that's about all I can say.
Right. And that's really my point. You know, even if we agreed that we are both going to use the same time management software in the same environment, we still have to have a discussion about versions, right? Even then.
Oh, sure.
And ownership.
Right.
Because you also have that issue. That's why open sources are being very important, because you're not going to have just one company that decides, well, we're no longer going to offer that service or no longer going to offer that software anymore because we're in profit, and then that whole infrastructure is gone.
Right.
And it could be very good and very useful, but when it's privately owned, that's difficult to standardize.
The longevity, right?
The
longevity of something. So even if we decided that we were going to use XYZ software on XYZ platform and XYZ version, well, how long can we keep to that? You know, given that these vendors are just changing stuff at their whim, whenever they feel like it, you know, under whatever circumstances they need to make a change to.
Well, our thumb drives are running out of read-write cycles and our CDs are rotting, you know, in the next 20 years also. So it is a problem.
Yeah. And if I'm going to base science on that and engineering on that, you know, the people at, you know, when they put those robots on Mars, right? They're not doing patches and security updates, you know, and changing that hardware software. They're stuck with whatever version of the hardware and the software they have, and they have to have people and knowledge that deals with technology from 10 years, 12 years, you know, 20 years ago, because that's when that stuff was originally designed. But here on Earth, our software has the shelf life of, you know, what, 30 days maybe. You know, things are being updated faster than we can update, right? And so, you know, I don't know if you got the point where we said that standards are necessary but not sufficient. They are a step in the right direction, but by no means do they solve the problem.
Yeah, I followed that.
Yeah. Not even close. And the fact that we all have different platforms and different versions, and Tracy is running Zoom right now, and her Zoom has some features that Julie's Zoom doesn't have. I don't know what Jennifer is using. I don't know what you're using. John is connected in some other kind of way. We're recording this data and recording this meeting. Some of our recordings are happening in 16 bits. Some of the recordings are happening in 24 bits. That's just, the data is actually different for this same conference. And you might say, well, isn't it recording the same thing? Well, some applications are going to process 24-bit data a little differently than 16-bit data. Right, Julie?
Well, not only that, but, you know, like, I'm the one capturing this, right? And you guys are going to, what we get is a unique perspective on it, right?
I'm capturing it too.
Yep, right. Well, I'm recording the video and the audio, right? Yours are going to be different, right? But what we end up with for the archive is a unique perspective of this event. Right. But it may not be the perspective everyone else had.
Yeah, that's absolutely the case. And what archive you're going to put it at? Cloud 1.0 or Google Cloud 2.0?
It's going to go to Google Drive so Tracy can get it.
Yeah, there we go.
Google Drive's good.
Version left to Google.
Right. And let's pray that Google stays in business or doesn't get bought out by Amazon or eBay or whoever, right?
Because, well, I hope not, because my whole music collection's up there.
Yeah, there you go. Right. There you go. And remember Enron? Do you guys ever remember that name?
Oh, yeah.
They were a pretty large energy company, and some would say they were too big to fail, right? Right. So it's not implausible that YouTube goes away with all of that video. That's not something that can't happen. It's not the case that Google can't be gone tomorrow. I remember something called MySpace. You guys remember that?
Yes.
Right. Where are they now? Right. Where is AOL? You've Got Mail. Remember You've Got Mail? That
Yes.
was huge. That was an international thing. Is AOL even around anymore?
Yes.
I think John still has an AOL. He has an AOL email, right? How's that working for you, John? Right. That's.
I know other people that have AOL.
Right. We don't have a periodic.
Yeah, AOL.
Huh?
I mean, AOL still works, I guess. They did drop POP. They did drop support for POP recently.
Right. Exactly. So yeah, right.
And then the actual company, they merged with Yahoo to form Oath.
Oh my God. Right.
So
think about all those poor scientists that are using AOL as their information infrastructure. And I'd be willing to bet this house that there's at least one scientist that is on AOL right now. I'd be willing to bet.
Oh, probably a lot.
Because John is a mathematician and he's still on it. Right.
yeah.
Yeah, exactly. So there's going to be some scientists and some scientific research tied to it.
Oh, yeah.
And then you wonder why we can't replicate results.
Well, we're going to end it on that note. And again, I would like to thank everyone for participating. Jennifer and Tom, very glad to see you. Hopefully, we'll have some other discussions in the future that you guys will be interested in participating in. I just want to let everyone know that, again, this is recorded. And we're going to have a video that we will make available to everyone to see in the future, an audio as well. There is a discussion that's going to go on I forgot the date, but it's sponsored by the Brookings Institute, and it's about automation in the middle class. And can they access that through the Neo? There it is. So this is a PDF. Can they? So this is on.
Yeah, I put that on the Google Drive link as well.
Okay, so you guys will be able to download it. It's going to be Tuesday, December 8th, 11 to 12:15. I've looked at a number of the Brookings Institute's, they'll have webinars and discussions, and they're really good. So this is something that's very interesting. I think would be interesting to our group. So again, thank you very much for participating. We hope to see you in the future. Everyone stay healthy and have a good and happy holiday season.
Thank you.
Thank you.
Yeah.
You too.
Happy holidays.
Bye now, everyone.
Okay, bye-bye.
Bye-bye.
Thanks, Jen.
See you guys.
Bye-bye.